Continuing now, log functions, okay? So addition and subtraction are inverse operations. Multiplying and dividing are inverse operations. Raising to powers and logs are inverse operations. So for example, 2 cubed is what? 8. Good. Another way to, so 2 cubed is equal to what? Well, then you would say 8. But what if I said 2 to the what is 8? The answer would be 3, but they just didn't write it like that. Because 2 to the what is 8. So the way you say that is 2 to the what is 8. 3. The log just tells you to do that. So 2 to the what is 8, 3. So if I have log 2 to the 16, that means 2 to the what is 16, and that would be 4. 2 to the what is 16. Turns out x would be 4. So it's just another way to write it. So if I wrote, 3 squared, that's 9. But if I wrote log, that means 3 to the what is 9, 2. So if you see log, think of to the what. Okay. So this graph right here, the graph of 2 to the x. So here's the table. So at -3, I get 1/8. -1, 2, 3, I get 1/8. -2, I get 1/4. This, at 0, I get 1. At 1, I get 2. 2, I get 4. 5, 6, 7, 3, I get 8. So remember, this is a asymptote down here. So this is 2 to the x. The inverse of 2 to the x is log 2 to the x. So this inverse is log 2 to the x. So then inverse function, you flip-flop everything, so it's going to be 1/8 -3. 1/4 -2. 1/2 -1. So 1, 0, 2, 1, 4, 2. 8, 3, 16, 4. And now I'm going to draw on y equals x. All right, so that's y equals x, and all right, so 1 I get 0, 2 I get 1, 1, 2, 3, 4, 1, 2, and 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So this is going to do this. And that's log 2 to the x. But this is going to be an asymptote down here. Because if the x-axis was an asymptote for the exponential function, that means the y-axis is going to be an exponential for the log function. So the domain here is all reals. The range is 0 to infinity. The domain for the green is 0 to infinity. The range for the green is all reals. Do you guys hear that noise? You can't say anything either because you'll get yelled at. You just gotta bite your lip and smile. Just a lot of unnecessary noise. All right. Okay, that's, you guys can read that. That's not. Okay, you guys could read that. Just watch. So write the following exponential equations into log form. So this is what I do. Circle, keep the 8 there, and just write the word log. So you got to switch it. So the 8 always stays there, but then you put the 64 as the exponent and the 2 is the answer. But you have to write the word log. Anytime you do the switch, you either take away or you write the word log. I don't like looking at it like this. So I write 2 cubed equals 8. Switch. Since I made the switch, I got to add the word log in. And that makes sense. 8 squared is 64, right? 8 to the what is 64? 2. 2 cubed is 8. So, equivalently, 2 to the what is 8? 3. All right, I don't like it looking at it like this. So, 2 to the negative 1 is 1/2. 1/2 is a number, so switch these two. So log 2 to the 1/2 is -1. These down here are written wrong. The equal sign should be no, we have to rewrite these. So it's log, these aren't typed right. 381 equals 4. So the 81 is on the same line as the log, and the 3 is a subscript, and then equals 4. So because there's a log, circle, but now that I'm making the switch, I don't write the log again. You either take the log or delete the word log whenever you make the switch. Same thing here, that's gonna be log 7 subscript, write the 49 right next to the log, equals 2, switch, 7, 2 is 49. And this one's written okay. So that's 4 to the 5/2 is 32. These are just written in different forms. Okay, so all right, so this is going to end up being log 3/2 to the x. Oops. Log 3/2 to the x. And that's an exponential form. It's written like that. I'm not going to graph this. We already graphed the one on the first page, so you guys could just plug that in the calculator, graph that one. All right, so write the inverse of this equation. All right, so we have y equals 3 to the x. I have to write the inverse, so I switch x and y. Switch x and y. I don't like seeing it like this, so I do 3 to the y is x, circle, add the word log. So this is that's my inverse function. So I wouldn't write the word y there anymore, I just write inverse. So if I have 3 to the x, that means the inverse function is log 3 to the x. If I have 4 to the x, the inverse function is log 4 to the x. If I have log base 6 to the x, that's 6 to the x. Same thing here. So that would be the inverse would be a to the x. Okay, transformations on log. So if I give you a log graph, see, log graphs always look like this. Let's see if I have a piece of graph paper. They always do this hook. So if I have log 2 to the x, well, you could put it in the calculator. Alpha, no, y equals, and then do alpha window log 2 x. Then hit second table. So 1 I get 0. At 2 I get 1. At 4, 1, 2, 3, 4, 1, 2, I get 2. And then these do this. Because this is an asymptote right here. That's log 2 to the x. So if I were to do log 3 to the x, it always goes through the same point here, but so 3 to the x means at 1, 2, 3 I get 1, 9 I get 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, I get 2. That would be log 3 to the x. So I could do transformations on these graphs. I could shift this graph to the left, like 5. So if I had log 2 x plus 5, that would be to the left 5, which means I'm also going to move the asymptote. 1, 2, 3, 4, 5. And all the other points, 1, 2, 3, 4, 5, move to the left 5. If I did log 2 to the x plus 5 like that, that would be up 5. So it's the same idea. Same idea as the other transformations. So in this case, log 5 to the x is your basic function. Then we go right 7, multiply y's by 2. This one I get log 5 to the x, left 2, multiply y's by -3, or multiply y's by 3, reflect over the x-axis, and then finally I go up 1. All right, what do these expressions equal? What do these expressions equal? Well, I could do it right on my calculator.
Hey, you want them to go in the basement? Get off it. No.
327. I get 3. So 3 to the what is 27? 3. 5 to the what is 1/25? -2. 8 to the what is 32? No. Okay, so you could do 3 to the what is 27. 3 to the what is 3 cubed, and we're back to, well, when we were in school and we were doing these types of problems, dropping the base. 5 to the what is 1/25? 5 to the what is, well, that's 5 to the -2. 8 to the what is 32? 2 cubed x. 32 is 2 to the 5th. Drop the bases, 3x equals 5, x equals 5/3. Let me evaluate that, and then I'll times the answer by 2. 4 to the what is 1/16. So that's 4 to the x is, well, you really don't write, I shouldn't do that. You really don't write x equals here because it's not an equation. So you could do it this way, but then at the end, you know, your answer is, that's just your answer because it's just an expression. It's not an equation. But 16 is going to be 4 to the negative 2. So x is negative 2. So it's just negative 2 times this 2, negative 4. So if you don't believe yourself, 2 alpha window log 4 1/16, negative 4. Okay, if you have the old operating system, I should have mentioned that. So let's say you want to do log 2 to the 8. See, this calculator's got the old operating system. I can't do alpha window. So what I would do is this. Log 8 divide log 2. You get 3. So you've got to split this up. So do log 8, whatever that is, divide log 2, whatever that is. The logs don't cancel because that would be 4, and that's not correct. So log 8, enter, divide log 2, enter. And 2 irrational numbers will give you 3. All right, now this one, this is weird. That's 3 to the log 3 to the 9. Well, 3 to the what is 9? 2. So now it's 3 squared, which is 9. So these actually cross out, and you just get 9. But, all right, so 1/2 to the what is 1/4. 1/2 to the what? 1/2 to the what is 1/4. Well, 2 to the negative 1x is 2 to the negative 2. So negative x equals negative 2. So x is 2. X is going to be 2. So that's 2. 3 to the what is 81. 3 to the 4. So that's 2 times 4 times 18 to the what is 324. 18 to the what is 324? 18 cubed? 18 squared? Oh, good. 18 squared. So that's a 2 times 1/2 is 1. So that's 8. What song are they listening to? Oh, the milkshake. That's nice. 3 to the what is 81? 3. 4 to the what is 256? I think it's 4t. 4 to the 4. Yeah, so that's 4. 2 to the what is 64? That's a 6. So 7 minus 6, that's 1. Or you could just do them in your calculator individually. All right, now this one we're actually going to solve for x because it is an equation. So circle. 2 to the 4 is x. So 2 to the 4, x is 16. Circle it. 81 to the 1/2 is x. Well, 81 to the 1/2 is really radical 81, which is 9. That's a b. So b cubed is 27. So to solve for b, I raise both sides to the 1/3. So b equals 27 to the 1/3 is 3. b to the negative 3 is 8. So I'm going to negative 1/3. So b equals 8 to the negative 1/3. One half. So we're going to plug in 64. So f of 64 log 4 to the 64. 4 to the what is 64? 3. And all right, done.